Okay, so today what we're going to do is we're going to begin our look at some measurements of geometric shapes. And the first thing we're going to talk about is perimeter. And we're also going to talk a little bit about circumference, because circumference is the equivalent of perimeter but for circles. And then we're going to do some lessons about parts of a circle so that you can identify the different parts of a circle and information about them, because it's going to be important to you. Okay?
Did we already do this one?
So.
I think we did this last time.
So. Okay, so let's start by talking about perimeter. You've worked with perimeter before. Perimeter is the easiest piece of geometric measurements, because anytime you're asked to find the perimeter, remember that simply means the distance around an object. And it doesn't matter what object you have, it just means the distance around, okay? There is no formula for perimeter, although many people try to use a formula for perimeter for a rectangle. But really, all you're actually doing is just add all the sides. So you just take the measurement of each side and add them all together, and that's perimeter. Right? Doesn't get any harder than that. Now, for your level, though, you can also have some shapes where they give you most of the measurements, but not quite all of them. Right? But if we know most of them, we can find the others by just thinking of some principles of the shapes. So let's look at finding the length of a missing side. Now you can use algebra to be able to do this. Some really simple algebra. So, say for example, we have the following shape. Right? What shape is that? A rectangle. Remember, you must be able to recognize the shapes, because you're going to be given a formulas page, although not for formulas for perimeter, but for the other type, for area, you'll be given a formulas page, but it won't have pictures of the shapes on it. It's just going to give you the formula, so you have to be able to recognize the shapes. All right. So we have a rectangle, okay, and let's say that it says that this is 2 meters and this is 4 meters. Right? Very easy on this one, because what do we know about about rectangles? That if one side is 4 meters, the side what?
2 meters.
Opposite it. Right, the side opposite this. So it's made up of sets of parallel lines, so the sides opposite are always the same length. Right? So all we have to do is take 4 meters plus 4 meters. Notice I'm using units. Plus 2 meters plus 2 meters equals what? Pardon?
16.
Okay. All right, that's all right. Okay, 12 meters.
Wait.
Okay?
Please. How do I explain what you just said?
All I did was take each side and add them together.
No, not that. But I mean, the finding the missing.
The missing sides? Well, in this case, we know the properties of a rectangle. That opposite sides of a rectangle are always equal. Opposite sides of a rectangle are equal. Okay? Now, all right? So, what if we had this shape? Now, I'm going to put the little 90-degree angle things in each corner, because my drawing doesn't really look so square, does it? But if it has 90-degree angles in each thing, and okay, or I could just do this. What does it mean if I do the little lines on the side? They're all the same. Good. So if I say that this is 3 meters, then what? They're all, yeah. And so you could either do 3 meters plus 3 meters plus 3 meters plus 3 meters, but what is the operation that literally means repeated addition. Multiplication. So we could also do 4 times 3 meters. Either way. So you can multiply them if you want to. You don't have to write it all out as addition if you can see that it's multiplication. Doesn't really matter. You're still going to get what? 12 what? Meters. Okay? All right? Now, what if I have... Okay. This shape. Does it matter?
It looks like a finger pointing, like a
No, it's like that.
gun.
No,
Okay.
it looks like. No, it looks like a thumbs up
All
on
right.
the side.
So what if I say that this is 5 meters, this is 2 meters, this is 2 meters, this is 2 meters, this is 1 meter, and this one I don't know.
2 meters.
Okay?
What?
But then I tell you that the perimeter of this object, and perimeter is always capital P, by the way. If the perimeter of this object,
Will you be marked down for accidentally putting out a lowercase p?
no. Okay?
Sorry about you.
All right. So if I say the perimeter of this is 12 meters, could I find the area of the length of the missing side?
Yeah.
Yes. Simply, you could either. Oh, what did I do? Oh, okay. All right. So I can't add.
Make it 14. Yeah.
30, 15.
I got to make it smaller.
What?
I got to make it bigger.
That means it's minus 1.
I don't want it to be 15. It's got to be smaller than 15 though, because that can't be 4 meters.
14.
I'll do 14. There we go. All right. So if you know the total, you can simply create an equation using all the pieces you know. Now, you would probably not write all of these these pieces you know out, right? And then solve.
Should I
Now-
write this down? Yes. Like the entire shape?
Okay. Now, if you were doing this, you could have combined all of those like terms, or you could list them out. Either way. I'm not going to be looking for you to list them out. If you put the entire total, that's fine. So it's just 14 meters, and 5, 6, 7, 8, 9, 10, 11, 12 equals 12 meters plus x. Then what?
You minus 12 and inside it.
Subtract 12 meters from both sides to get the x by itself, which gives us 2 meters equals our x. So our missing side is simply 2 meters.
Okay, can you just
Okay.
measure the
So
2 meters
add up
and
the one-
measure that one and then...
And they're not going to be drawn to scale on a test. Do you think that's 2 meters?
No.
Yeah.
Oh, no.
So
But like,
The
can
1
you
meter is
measure
the same
like...
size as
Can
2
you measure, like...
just use algebra. That's the whole point behind us looking at algebra. Remember, everything you do from here on in your future math is going to be based on algebra. So use the algebra. So yes. So you can add them up and then put them in to create an equation. Guys, hold on. Shh. You do not have to show all of these pieces if you don't want to. You could combine them first and then put them in.
Will you get marked down for not putting them in? Or will you get marked down?
I want to see this,
What do you want to see?
the part I circled.
Okay.
I want to see that you make an equation of it. I'm going to give you easy problems so that it's not a stretch for you mathematically, so that you can concentrate on writing out the problems correctly. All right? I can give you problems where you have to write it down just in order to be able to do them if you'd like. Would you like to have some
What?
567.6932 as the side, or would you rather me do 5?
5.
So pick one. You can either use easy problems and show me the working, or I can give you problems where you have to show me the working. Pick one,
So you have to show.
or else you would never get it right. Okay? So make sure that I realize I'm giving you these kind that you could really do in your head, but that's so that you can scaffold it and not have to work so hard on it. You're just really concentrating on the idea that you can use a simple algebraic equation to find the missing side. Okay? So if that's the point, that's the thing I want to see.
Okay.
Right? Okay, we're good? All right. Now, so this was an irregular shape. It didn't matter. Again, perimeter of any shape, you just add up the sides. Okay? We're going to talk a little bit about circles.
It says simple
Okay?
Can I? Okay, I'm just gonna go with it.
You guys, come on. Let's just finish. Okay, so here we go. So for circles, we need to know a few things, and we're going to talk about some parts of a circle. Now, it's not an in-depth look at circles where we're going to be talking about every piece. We're just going to be talking about the pieces that we need in order to be able to get the work done that we're going to be doing. Okay? And hopefully you've seen some of these before. If I have a circle, and that dot is the center of the circle, okay? If I make a line that goes all the way across through the center of the circle, what is that line called? The diameter, okay? So, there you go.
The bone in your body.
The diameter is a line across, but again, it has to be through the what? Through the center. It can't be off to one side. It has to be through the center, okay? Then there's another one. What if I go from the center and I just go across halfway? What's that called? That's called the radius. Good. The radius is half the diameter. Because if a diameter is all the way across, then half of it would be the radius. So if I know the diameter, can I find the radius? Yep, simply by dividing it by 2, right? If I know the radius, can I find the diameter? Yes, by simply multiplying it by 2, right? So what if the radius is 4? What is the diameter? 8. Just double it, right? What if the diameter is 16? What's the radius? 8. Huh? So one of them is just twice as big as the other. You have to remember which one is which, though. There's another thing that we need to talk about when we're using parts of a circle, and that is the idea of this little symbol, which is called pi. Now, pi is simply a ratio dealing with circles, but it's important because circles don't have sides like that we can measure. Okay? Circles don't have sides, about 4. All right, so we use this ratio in any calculation that we're working with when we're dealing with most calculations that we're working with when we're dealing with circles. So, pi, if you look on your calculators, all of you are supposed to have a scientific calculator, yeah? You don't have it now.
No, I just forgot it.
Does this count as size?
Okay, so you need to know how to use the pi button. I expect accuracy, so I expect you to be using the pi button on your calculator.
Sure.
Okay? So, unless I ask you to estimate. If I ask you to estimate,
What happens there? Holy moly.
then I will tell you the value to use. Now, guys, when you're estimating or you're told a value to use, you must use that value. If you use the wrong value when you're told to use a specific value, it will mean your answer is wrong. Okay? So, some of the common values for pi, for the estimations, sometimes you'll just be asked to give an estimation, so you just use 3. And that's perfectly fine. If you're estimating, do you want a bunch of decimals? No. Okay? The most common estimation for pi is 3.14. Okay? Not quite. So, yeah. The one Education Perfect likes to use is the estimation 3.1416. They've rounded it up.
It's 1.142.
Okay? So again, depending on the problem. But if you're working on a problem for me and it does not give you a value, then what are you going to use? The pi key on your calculator. So you need to practice with it. Okay? All right?
Would you also be given 22 and 7? Because that's what was in the last one.
Whatever it tells you. Yeah. So there are tons of different estimations for pi. Again, you use the one you're told to use. And if you don't use the one, then I know you didn't read the directions, which means you're not going to get credit. Okay?
Times it by something that near the end.
All right? So you just have to round it. Okay? Now.
No, but if you're like pushing the pi button,
Okay.
pi near the ends. So how many?
So what we want to talk about is, remember that the distance around objects is called the what? Perimeter. But that's only when you have what's called a polygon. Which means a closed shape. That means no breaks in it. Okay? And straight sides. Well, what we're dealing with is a circle. It is closed, right? A circle is closed, but what does it not have? Straight sides. So it doesn't have perimeter. Instead, the distance around a circle is called circumference. And perimeter doesn't have a formula, right? You're just adding the sides. But circumference does, because it's different. It still means the distance around, but this is the only one that has a formula. And the formula for circumference is circumference equals pi times d, which stands for the diameter. And that's usually, for you guys, written as circumference. Circumference, let me just erase that bit. Circumference equals pi d. Because when you cram pi and the d together, what operation does that automatically mean? Multiplication. Right. So you might see it with the multiplication, but more often than not, it will just have pi d. Okay? All right. The other measurement for circles that we need to talk about is area. And again, every calculation that you do with circles is going to involve pi. But for area of a circle, area doesn't mean the distance around. That means the space inside. Remember, we talked about that when we talked about the kites and etc. For area of a circle, that's pi r squared. And what does r stand for? The radius, right? And if it's squared, that means you're multiplying it times what? Itself. There you are. Times itself. And then you multiply it times pi. So you're going to need to practice. You're going to need to practice these keystrokes. Remember, for your order of operations, if I have that exponent and the pi, do I multiply pi times the radius first? No. Order of operations tells me I have to do that exponent first and then do the multiplication, right? So what you would do is you would take the r and square it and then multiply it times pi. Okay?
Yes.
So make sure you square that first. And square it doesn't mean multiply by 2. It means multiply it by what? Itself. Okay? And you can use the square key on your calculator if you like. It's perfectly fine. Yes, ma'am.
If you're using radius, why can't you just do diameter if you're doing it by 2?
Because it's not doing it by 2. It's squaring it. Look. So let's say I have a circle. And this is the diameter. And the diameter is 4 meters. Right? If I take 4 meters times 2, that gives me 8 meters, right? The diameter is 2 meters, because it's half of it. 2 meters times 2 does indeed give me, the 4 meters that I started with. But the formula is not times 2. The formula is pi r squared. So if the diameter is 2 meters, what does squaring it mean to do? Right. So 2m times 2m is 4m squared. Okay? So you're getting a different value. Now that was a crummy example because I used squares. Let's use one that doesn't do squares. say it's that the diameter is 6. This is a really good one. Okay? So what does that make the radius? 3 meters. And if I take 3 meters and square it, what do I get? 9 meters squared. Remember, don't forget to multiply the m times m, right? And that's why I always include the units when I'm working on any of these. Okay? So is 9m the same as 6m? 9 meters squared the same as 6m? No. So you see it's a different operation. It's not multiplied by 2, it's squaring, which means multiply it times itself. Okay? One thing I want you to be very careful of, and this is for anything that you do in mathematics or algebra especially. How important do you think this is if I'm going to use 2 lines and write in capitals? Never replace a variable. There you go. A variable without using, it's as close as I've ever gotten to yet really yelling at y'all, using a bracket.
Can you give us an example?
Of course. Okay?
Let's just keep that on the board.
All right. If you don't use a bracket, then what happens is you change the operation. Okay? And I can tell you that there were lots of Year 11s who took the MCAT last year who would have gotten excellence if they'd used a bracket. Instead, they got achieved. That's that's hard.
So if they used a bracket, they would have gone from achieve, which is the lowest, to excellence, which is the highest.
Right, because... Huh? Okay.
A
A variable without using a bracket.
Did you tell me
Okay.
Year 11?
Because watch what happens if you do something. So let's just say you had 14 equals negative 2x squared plus 4. And I want to do that when x equals 2. Oh, 3. You like 3? Okay, 3. Okay? So here's what they did was, okay, now let me change it slightly. That's not exactly what they did. Hold on. So let's just change it. Negative x squared. Make it even simpler. X squared. Now, watch what happens and say that's negative 3. So x equals negative 3. So in place of x, all I have to do to this problem to get it perfectly right is put negative 3 in place of x, right? Watch. What they did was this. Whoops, sorry, no bracket, of course. Anybody see an issue with that?
Positive 9.
Exactly, because it's 14 equals negative 3 quantity squared. The negative and the 3 need to be squared. And simply because they didn't use a bracket, they kept that negative when it should have turned into a positive.
Either way, the equation doesn't work.
Wait, if
14 doesn't equal.
Yeah, well, yeah, that's true. But I was just giving you a for instance. Okay?
so if minus 3, you know the first one where they did it supposedly wrong?
Mm-hmm.
Wouldn't you, if you did a minus 3 squared, wouldn't you have to get 9 either way?
Well, yeah, but they were getting negative 9.
Why? How did they get negative 9?
Because they saw the 3 was squared, but then they just kept the negative.
But you're not supposed to do that anyways.
Yeah, you're supposed to put it in brackets so you can see that you're squaring both the negative and the 3. What you're squaring is a negative 3, not just a 3.
If you saw that equation, if you just saw 14 equals minus 3 squared plus 4, wouldn't you square the
No.
minus?
This means only square the 3. What is the thing the exponent is touching? Just the 3. This means square the negative and the 3. They were getting the meaning right, but they had written it wrong.
What deal with these people you're leaving?
Yeah.
So that
And it's very common. So, and I'm telling you, you guys, y'all don't do, that be careful.
So
Okay.
don't do that.
Yeah. Do this, not this. Right? It changes the meaning of the expression, which is the whole point. Okay? All right. Well, the equation in this case. All right? So let's say we have a circle, and I give you this line, and I tell you it's 3 centimeters. Okay? And I want you to find first the circumference of this circle. Okay? Go. And I'm going to call on somebody. Find the circumference of this circle. Yeah, you should be finished in about 2 seconds.
Wait a